Well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Is everybody doing good? Yes? And everybody with their mask on and everything? Good? All right. Warm-up number 7's on the screen. Number 1, read, simplify 6y plus 2 plus 3x plus negative 2y plus negative 5 plus 4x. Number 2, read, solve. Negative 6m minus 5 plus 3m greater than 22. And number 3 is also solve. Negative 1/2 x plus 2/3 less than or equal to 5/6. Copy that and solve those. It shouldn't take you more than, what, 5 minutes, 6 minutes? 5 minutes, all right? Let's do this. All right, let's see what we got. Number 1, Noor, what'd you get? 4y plus negative 3 plus 7x. All right. Now, yesterday, Miss Zamora said that we were going to organize this in standard form. Now, just to refresh in your memory, here it goes again. How do we organize it in standard form? We go one term at a time. I'm going to start with this term. You look at the exponent on the variable. What is the exponent on this one? 1, okay. Look at the next term. What is the exponent on the variable? It doesn't have a variable, so if it doesn't have a variable, it's 0. What is the exponent on this variable? 1. So now we need to arrange them from highest to lowest. But since we have 2 of the first degree, now we look at it in alphabetical form. So which one comes first? So it's 7x, and then 4y, and at the end, minus 3 or plus negative 3. So far so good, yes? All right, number 2. What do you get for number 2? How about Bella? What you get? The negative 9. Less than negative 9. Hands if you got that. Good. Some of you forgot to flip the inequality symbol. Remember, at the end when you divide or multiply by a negative, you flip the inequality symbol to the other side. Okay? All right. Bella, pass it to someone, please. X is greater than or equal to negative 1/3. Hands if you got that. That is correct. Now, for those of you that are struggling with these, remember, always start with the common denominator, which is 6. You distribute, that becomes negative 6/2x plus 12/3 less than or equal to 30/6. Then it simplifies to become negative 3x plus 4 less than or equal to 5, and the rest is history. Okay? All right, the agenda for today, here we go. Agenda for today, warm-up number 7. From there we do absolute value equations and inequalities, and your home plate is going to be a play sheet with only 10 problems, only. Copy that. All right, once again, warm-up number 7, absolute value equation inequalities, play sheet, and 10 problems for tonight, and adjourn. All right? All right, get last night's home play in front of you, please. Those of you that are watching online, if you want to follow along the lesson on Nearpod, your code is G43YW, G43YW. All right. So before I go over some of these, I want you to turn to your neighbor, go over number 4 and number 5. Make sure they have the same solution set and graph. Number 4 and 5. All right, let's see. Numbers 4 and 5. We're looking at 4 and 5. I'm going to start with number 4. Number 4. What you get for number 4? Raymond, what is your solution set for number 4? What did you get? Solution set as such that, what else? less than negative 2.5, yes. Okay, hold on. Then we need to write or, and then S is what? Greater than or equal to 4. Hands, if you got something like that? Yeah. And what do you notice on the graph? The graphs are going in opposite directions. Yes? Yes, Mr. Q. All right, good. Number 5, Sky. What is your solution set for number 5? Solution set? Hold on. We always start with the variable x such that, and then 1
is
less than x.
And x is greater than, no,
Less than or equal to 4. Hands, if you got something like that. That is correct. And what do you notice on that graph? They both overlap like so. If you graphed it. Okay. All right. So yesterday we weren't able to get to the graphing portion, but I said you can go to the video. But if you didn't go, I'm going to go over the graphing portion right now. So let's go to number 6. Here it goes. When you write an inequality from a graph, start with a dividing point. What is my dividing point here? Where does it start? At 6. Okay. Next, you look at the shaded region. It's over here. And we're going to label that a variable because we need it for all the numbers. So I'm going to say x. Okay? Are we there so far? Next, I need to know which direction I'm going to write my arrow. This is how you check. Pick any number from this section. I'm going to pick the number 2, and I'm going to compare it to our dividing point. So let's read it. 2 is what compared to 6? Less than. That is correct. So that's how we write our arrow there. Now, do we need an equal sign? Look at the point. Is it a closed point? No. We leave it like that. And now that we have our inequality, we just write solution set of x such that, and you close it. Write that down, please. Make sure you get that. I need you guys to be solid on these solution sets, please. Okay? Let's do number 7. Number 7. What is our dividing point? It's in between 2 and 3, so it would be what? 2.5. Okay. Then we need a variable for the arrow that's shading all the way to the right. I'm going to change now from x, I'm going to change it to y now. Does it matter? No, it doesn't matter. I'm just using a different variable. So, now I'm going to compare 2.5, which is right there, to any number over here, let's say 4. What is 2.5 compared to 4? Less than. So I'm going to write 2.5 is less than y. And then I write what? Solution set of y such that, and then you close your solution set. So far so good, yes? All right, let's go to the last one, the big kahuna, this one. Who notices now that we have 2 different graphs on the same line? Okay, so here it goes. How do we do these? First of all, who notices that the 2 graphs do not intersect? They go in opposite directions. That means this is a what kind of inequality? So the first thing I do is write the word or, because those 2 graphs do not intersect. The only ones that intersect are the and inequalities. Okay, look up. There we go. I'm going to start with this one. What is my dividing point? -5, and I'm going to label this x. So I'm looking at -5. I'm going to pick a number from here. Let's say this one. What is -8 compared to -5? Less than. Okay, so I do that. Look at this point. Is it a solid point or an open point? Solid, so that means I'm going to put an equal sign right there. Let's go to this side. Dividing point is 3. This is still x. And I'm going to compare 3 to 7. What is 3 compared to 7? Less than. That means I'm done. Solution set of x such that those, and close your solution set. Pretty straightforward, yes? All right. So, with that said, get a Cornell note ready, please, for today's lesson. You do need a prayer model. And put away that home play. I'm not picking that up today. You're like, what? This is cute. I did it with colors and everything. Good. That's good, right? Extra practice for you guys? All right. And your home play for tonight is a play sheet. Could I get the last person on each row? Go get a play sheet for your row. They're over there on the iPad card. And as they're doing that, quick recap on how we started with one variable equations and inequalities. We started off that we did scales, right? If it's balanced, it's an equation. If it's not balanced, it's a what? Inequality. And then we did a couple of these and so on and so forth. All right? So our objective for today, you can solve one variable equations and inequalities. Where do you write that on your Cornell notes? At the bottom left. Bottom left. One variable equations and inequalities. I can solve one variable equations and inequalities. So our main concept for today, what is it still? One variable equations and inequalities. And what are we still doing? We are solving. So once again, today's a packed lesson, so go like this, everyone, go like this. Bear with me, yes, because it's going to go pretty good, right? It's going to go pretty fast. It's going to go like this. Look, Miguel. Saw that fast? Yeah, pretty good, yeah. All right. So, your prayer model. Write one variable equations and inequalities. One variable equations and inequalities. Now check this out. Without looking at your notes, pay attention to this part. Without looking at your notes, give me a definition in your own words of what is or what are one variable equations and inequalities. Give me one example and one non-example. I'll give you some time for that. Go. All right, good. So once again, you should have written something to the effect of with one variable, either two expressions equal or not equal to each other, or an equation with one variable, inequality of one variable. Example, something like this, and non-example, something like this, and your hashtag, yes? All right, last time I asked you guys to write 4 steps. Remember those? Don't write these down. We already know these. Simplify, isolate, plot, and check. Have we been doing that for the home plate? Yes. We've been doing the entire process. We're going to continue today. However, for today, we're going to have something just a little bit different. So I want you to write these steps down. Write those down underneath your prayer model. 3 steps. And it reads, number 1, isolate the absolute value by using inverse operations. Number 2, write 2 equations without the absolute value symbols. And step 3, solve each equation. Copy that. I'll give you a minute. Our 3 steps that we're going to follow today are the following. Once again, you isolate the absolute value using inverse operations. Step 2, you write 2 equations without the absolute value, and I'm going to explain and elaborate on that. And number 3, solve each equation. Okay? So what do you guys notice that's different today? That we're looking at what? Absolute value. Now, I'm going to break it down once again. Those of you that were already with me, this should look familiar. Those of you that have not, this is going to be the first time you see this or this approach. Here it goes. What is absolute value? Well, absolute value is the distance of a number away from 0, the distance of a number away from 0, the distance of a number away from 0, the distance of a number away from 0. Okay? What's another way of writing it? Well, we use what symbols? 2 bars. Why do we use 2 bars, by the way? Does everybody know? Okay, good. Because it's the distance from here to here. You're like, what? Yeah, from here to here. That's why we use how many bars? 2. Because it's the what? The distance of a number away from 0. Is that a little bit excessive? Yeah? No, right? So what is it? What is the absolute value? From the corner, let's go. Did he just say LeBron? Michael Jordan, what are you talking about? Detention. No, just kidding. All right, so once again, The distance of a number away from 0 is an absolute value. So think about that. Here it goes. If I was to ask, what is the distance of negative 23 away from 0? Here it goes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. How many steps? 23. Did I say negative 23? No. So what can we conclude? That absolute values are counted as what? Positive only. Does that make sense? All right. So another way of writing this or saying it is, what is the absolute value of negative 23? And how do you write that with symbols? Negative 23 with 2 bars like that. So how do we say, what is the absolute value of negative 23? Well, it's positive 23. There it comes. Why? Because it's the distance of negative 23 away from 0. Yes? Now let me present this in a little bit of different form. Look how it starts. What number? So they're assuming that you don't know the number. Is that correct? So that means that we add an absolute value with an x in the middle, because we don't know the number. What number is an equal sign, 23 steps away from 0, 23 steps away from 0. This is how you write it in symbols. Let me ask you the question. What number is 23 steps away from 0? Think about it. Tell your neighbor, what number is 23 steps away from 0? Brianna? 23, Michael Jordan. What other number? Vianney? What other number is 23 steps away from 0? Negative 23. So we have what? Positive 23 and negative 23. Okay. Now that we have the main idea, copy this. Example 1a. Solve the equation absolute value of x. Outside the absolute value, we have negative 3 equals 23. Just copy it. Don't do anything else. I'm going to go through the process. All right. Let me clarify something. Look up to the screen really quick. Whenever I talk about the absolute value, I'm thinking about this. It doesn't matter what we have inside. It can be a Pokemon. It doesn't matter. But when I say, is the absolute value isolated, what that means is it by itself on one side of the equation. That's what it means. Which means, is it by itself without a number there, without a number there, and without a number there? That's what it means, isolated, that there's no numbers around it. Could there be numbers inside? Yes, it doesn't matter what's inside. But outside, we cannot have anything outside. Is everybody following? Okay, let me go back to the problem at hand. Writing utensils down, look up to the screen. So, first thing I do, let me zoom out, line down the equal sign. Since I can't simplify anything on the left or the right, I go with the first step. Isolate the absolute value. That means leave the absolute value by itself. By using what? Inverse operations. Here's my absolute value. Is it by itself? What's outside of the absolute value? Negative 3. So how do we get rid of that? Inverse operations. Plus 3 plus 3. Absolute value of x equals 26. Copy that. All right? So we're done with step 1. Writing utensils down, look at the screen. Let me go over the next step. Step 2. Write 2 equations, but without the absolute value symbols. You're like, what do you mean, Mr. Q? Well, one equation for negative 26 and another equation for positive 26. Why those 2. Why 2 equations? Talk it over to your neighbor. Why 2 equations? Talk it over to your neighbor. We're talking about absolute values. So we should have said something to the effect, because there's 2 different numbers that are the same distance away from 0. Is that correct? All right, so that means I'm going to make one equation here, x equals negative 26, and x equals positive 26. Hold on before you copy. We're done with step 2. Look at step 3. Solve each equation. Can I solve anything else? No, so that means I'm done up to right there. Copy that, please. All right, so those are the steps. However, are we done according to the process that we learned before? No, we need a graph. Let's graph this. Here's my number line. 0, dot, 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 negative 26. Plot your point. Dot, 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 positive 26. Plot your point. And my solution set, look how I'm going to write my solution set using absolute value like this. Solution set, negative 26, comma, positive 26, and that's how you write your solution set. Not bad, right? Some of you things how come you're with E so far? 1 being the lowest, 5 being the highest, 4, 5, 5, 5, 4, 5, okay. Not bad. Let's do another one, yes? Okay, here we go. Example 1B. We got 8 equals absolute value x minus 2.5. Close the absolute value. We're going to do this one together. Yes? Yes, Mr. Q. All right, good. Here we go. Line down the equal sign. Look at the left side. We can't simplify anymore. The right side we can't simplify anymore. So let's go with step 1. Isolate the absolute value. Look at the absolute value. Is there anything outside of that absolute value on that side? No, so we're done with step 1. Let's go to step 2. What do we do for step 2? Write 2 equations. So I'm going to go 1 for negative 8, and then I got x minus 2.5, and 1 for positive 8 equals x minus 2.5. Step 3, solve each equation. So, what do I do here? Add 2.5, add 2.5. We end up with negative 5.5 equals x. Look at this one. Add 2.5, add 2.5. We end up with 10.5 equals x. Let's graph this. Dot, 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 5.5, and it's a negative right there. Dot, 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 10.5, and it's a positive. And are we done? No. Solution set is negative 5.5, comma, 10.5. Pretty simple, yeah? It should be coming back from back in the day in Algebra 1, yes? Or middle school or whatever, yeah? Or your other teacher here at the high school. So far, so good? Okay, let's do another one. Example Q. Write this down. Example Q, we got absolute value. Inside of the absolute value, you have 2x plus 1, close the absolute value, minus 3 equals 16. I'll give you a head start for that one, see how you do. Ready, go. All right, here goes the process, because one of the major mistakes or errors that some of you make is that you skip steps. Do not skip steps or you're going to start making little mistakes here and there. Here you go. Line down the equal sign. Step 1, isolate the absolute value. Is the absolute value by itself? No, we need to get rid of that 3. Is that correct? So we add 3 at 3. We're left with absolute value, 2x plus 1, equals to 19. Is the absolute value by itself now on that side? Yes. We're done with step 1. Go to step 2. Write 2 equations. So I'm going to write negative 19, and what's inside? 2x plus 1. And then we got what? And this is negative. This is positive. Positive 19 and all that to whatever's inside again, 2x plus 1. Are we there so far? We're done with step 2. What do we do at the end? We solve each equation, all right? So then minus 1, 2x equals negative 20. And lastly, divide by 2. X equals negative 10. How about this one? Let's see. Minus 1, 2x equals 18. And last, divide by 2. X equals 9. Hands, have we got something like that? Okay, let's graph this. Here's my graph. We got dot, 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 negative 10, it's right there. Dot, 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 positive 9, right there. So my solution set, negative 10, comma, 9, close set. Yes? So whenever you end up with a positive and a negative number, let's try and keep the negatives on the left side just so that we can keep our brain without making mistakes. And why on the left side? Why do you think we write it on the left side? Because on the number line it's on the left side. It's more, our brain catches it a little bit faster. Okay? Alright, so far up to right there. Show me what the fingers talking to you are with these. 5, 5, 5, 5, 5, 5. Okay. Alright. Example super Q, copy this. Example super Q. Let's do absolute value. A over 4 equals 3. I'm going to give you a head start. Let's see how you do with that one. Ready? Alright, let's see. Line down the inequality sign, the equal sign. Step 1, do we have the absolute value by itself? Yeah, so that means at this point I do 1 for my negative and 1 for my positive, so you should have written A over 4 equals negative 3, A over 4 equals 3, and then the last step we solve, so that means times 4 times 4, A equals negative 12 times 4 times 4, A equals 12, and my graph, negative 12, dot, 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 positive 12, dot, 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 solution set, negative 12, comma, 12. All right, one more of these. Let me move on. Let's go to example Shazam Q. Example Shazam Q. And we got absolute value, negative 5y, close the absolute value, equal to 15. Shouldn't take you long. Ready, go. All right, let's see. Solution set. Alexa, what'd you get? Negative 3 and 3. Hands if you got that. That is correct. You guys see the face? Pretty good, yeah? Bam. So once again, the process is the absolute value by itself, yes. So from there we do 2 equations, one for negative 15 and negative 5y, and one for positive 15, negative 5y. You know what to do from there, yes? Now, before we move on to the next ones, let me go back to the previous ones. Look up, please. So, we started with this one. Notice the absolute value is by itself. We got this number, and we got how many solutions? 2. From there, We got this absolute value by itself. We got this number. How many solutions? Okay. Absolute value by itself is right here, and we ended up with this number. How many solutions? Okay. And absolute value by itself, we got this number. How many solutions? Okay. Absolute value by itself, we got, whoop, that doesn't work, right? We got this number. How many solutions? 2. Okay. All right. Copy this one. Example 1C. Absolute value y minus 3, close the absolute value, plus 10 equals 8. Let's do the first step together. Y'all ready? Line down the equal sign. Step 1 says leave the absolute value by itself using the inverse operation. So what do? Subtract 10. We end up with absolute value y minus 3 equals negative 2. Stop right there really quick. Write any utensils down. Look up to the screen. Look at the previous ones. Look at that number on top, the highlighted one. Look at that one. Look at that one. What do you guys notice on all of them compared to that one? Tell your neighbor, what do you notice? So question to you. If we have an absolute value, could it be equal to a negative? Think about it, don't say it out loud. Could an absolute value be equal to a negative? Talk it over your neighbor. Could it be equal to a negative? Okay, let's see. Think about it. What is the absolute value? What do you think? What is an absolute value? What did we say it was? Rachel. We said that it's the distance of what? A number from 0. Okay, and how do we count those distances? Positive numbers, yes? So could we have a negative absolute value? That's why for these we write no solution. That only works when the absolute value is by itself equal to a negative number. Does that make sense? Or am I talking crazy over here? You're like, I think you're talking. Be nice. Do another one. Example 1D. Copy this. Negative 8 equals absolute value x plus 2 minus 8. And at first glance, what would you say this, the solution for that one is, Miguel? I'm sorry? No solution at first glance, right? Because there's a negative. However, is the absolute value by itself? No, we need to do that first step first before we make that final decision. Is it by itself? No, so what do we do here? Add 8, we're left with 0 equals absolute value x plus 2. So we're done with step 1. Question. You're like, okay, we have 0, it's not a negative. Is 0 a negative? No. Is it a positive? No, 0 is just 0. So check this out. So if we end up with 0, at this point we just do 0 equals x plus 2. Why only one equation? Because there's only one 0. There is no positive, no negative. So we're done with step 2. So let's go to step 3, which is solve. Minus 2 minus 2. We're left with negative 2 equals x. Graph. Negative 2. Solution set, negative 2. So let's wrap up this idea. So we've seen 3 different cases, is that correct? All right. Which are these? Look at them. Absolute value with how many solutions? 2. Absolute values with 1 solution, and absolute value with no solution. So let me start you out by doing this. Whenever you have an absolute value with 2 solutions, that means that we have the absolute value by itself, and it's equal to what kind of number? Positive, okay. For 1 solution, the absolute value by itself should be equal to what? 0. And the last one, the absolute value should be equal to what? Negative. Copy that, please. That's an easy way of looking at absolute values and know and predict how many solutions you're going to have. Copy that, please. So, up to right there, we covered the review for absolute values. So how comfortable do you feel with absolute values up to right now? Equations. 5, 5, 5. Yeah, we got this, yes? Okay. So this next problem, I'm going to use a word problem so you can see it in action. Okay, here it goes. Look up to the screen. Let me read the problem out. Example 2A. Don't copy this. It reads, Sydney Harbor Bridge is 134 meters tall. The height of the bridge can either rise or fall by 180 millimeters because of the changes in temperature. Who knows that metal changes with temperature, yes? If it's hot, it, flexes. If it's cold, it compresses. Okay? So with bridges, same thing. When the weather changes, the height is going to change because of the metal. So, if I was to ask you to write an inequality for this one, an equation, absolute value equation, look up. This is the setup that I would use. Absolute value x minus blank, close the absolute value, equal to blank. Copy this, please. This is the same setup for any time that I ask you to write an absolute value equation. Now, some of you might be asking, Mr. Q, why is it x minus? Once you get to transformations of functions, we're going to see this general rule that we're going to use, and you'll understand a little bit better. Right now, I don't want to get into the rule yet. This is just a soft introduction. Okay? However, we do know some information of our absolute values, right? On the previous ones, we said, look up, that this number became what? Negative and positive. Look at this number. This number became negative and positive. What number is negative and positive? The one that's by itself on the other side of the absolute value. So with that said, look up, please. Watch. If I was to tell you which of these two numbers will change positive and negative, let me read it again. The Sydney Harbor Bridge is 134 meters tall. The height of the bridge can rise or fall 180 millimeters. Which number goes here? What would you say? 180. Isn't the 180 that goes up and down? So I would write that right here, 180 millimeters. So if this goes there, what goes here? 134. Copy that, please. Example 2A. This is meters. Now, mind you, we can't solve it yet because they need to have the same measurement. Are they the same measurement? No, these is in meters, this is in millimeters, and we just need to convert it. Now, for your home play, there are no word problems. I just wanted to show you how to set it up. So you have only 10 problems for home play. Once again, the video will be uploaded at the end of the day. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye.